Hi everybody, I hope this video finds you well. In today's video, we're going to be taking a look at some examples of identifying statistical biases. Before we get to those examples, let's just go ahead and do a quick summary of the statistical biases that we're expected to know for our class. So, if you remember from the previous video, we discussed the following statistical biases. We discussed two forms of sampling bias, which were undercoverage and voluntary response bias. Remember, undercoverage is when a specific portion of the population, so a specific subset of the population, is missed based on the technique that you use to build your sample. Voluntary response bias is when individuals are allowed to place themselves into your study or sample rather than being selected. We also talked about four forms of response bias. There was general response bias, which can happen when you ask a sensitive question or a hard to answer question. We saw that there was wording bias when you ask a question that is either written with loaded or slanted language or written in a vague or unclear manner. There is also ordering bias, which is something that happens when you ask multiple questions and the order in which you ask those questions influences the responses. Remember, ordering bias happens only when we have several questions and happens due to a psychological phenomenon known as priming. Basically, where if you answer a bunch of questions about a topic, you might be sort of influenced to answer later questions based on your earlier responses. Then finally, there was also interviewer bias, which is where the choice of interviewer, either a physical interviewer, meaning an actual person, or simply the sort of presence of logos, titles of who's ever doing the survey, whatever, influence the people's responses. And then finally, we talked about non-response bias, which remember is simply bias that arises when you have a large portion of the people who are chosen for your sample simply not respond to your survey. Remember that there's a big difference between voluntary response bias and non-response bias. Voluntary response bias occurs when the individuals are not selected at all. There is no selection process. Non-response bias occurs when the individuals are selected but choose not to respond to the survey. All right, so we're going to look at three examples now of some different statistical samples. We're going to do a little bit of review, some stuff about categorical and quantitative variables as well, but we're also going to get a chance to diagnose the biases that might be present in these different samples. So basically, we'll be combining all the descriptive statistics that we've learned about earlier along with this new concept of biases. So let's get into these examples. So for our first example, we're going to suppose that El Camino College wants to study how well prepared students feel for an emergency situation. So to study this, the college randomly selects 200 students from a list of students who have signed up to receive alerts or information about emergency preparedness. They then ask each student, considering the suddenness and unpredictability of an emergency situation, how well prepared for an emergency situation do you feel you are? Very prepared, somewhat prepared, not prepared, or do not know. So out of the 200 students that are contacted, 53 respond, and we collect the following data. Notice that 12 people said that they were very prepared, 17 people said that they were somewhat prepared, 15 people said that they were not prepared, and 9 people said that they do not know how prepared they feel. All right, so we've got all our standard things to do here. We're going to identify population, sample, and individual. We're going to identify the sampling technique. So these are sort of basic terms and sampling techniques that we need to be comfortable with. We'll construct a relative frequency table for this data. Notice that this data is categorical. People are putting themselves into one of these four categories. So we'll construct a relative frequency table. Then we'll go ahead and discuss three possible sources of bias in the sample. So we'll say which of the 7 types might appear in this. And then we'll talk a little bit about a percentage of the sample that said that they were very prepared or somewhat prepared. And then we'll also try to sort of use the biases to diagnose whether or not we think that that percentage is an over or underestimate of the true percentage of the population. So let's go ahead and get started. So we'll start off with our standard population, sample, and individual. So if we look through here, we can see that we contacted 200 students, but only 53 responded. So our sample must be those 53 students, which makes our individual 1 student. What is the population here? Well, we'd want to say all students, but we are saying specifically all students at El Camino College. So the population here would be all students at ECC. That's the one we were trying to study, right? Because it said we want to study how well prepared students feel for an emergency situation at El Camino College. So we'd say all students at El Camino College. Okay, let's go ahead and talk about the sampling technique. So if we go back up here, we can see that they randomly selected 200 students, right? Now, they did happen to be students who signed up to receive alerts or information, but all we know is that they randomly selected these 200 students. Notice that they selected each student, so it's not going to be like a cluster sample, and they didn't do any sort of pre-division. They didn't say we're going to select some students from this list and some students that were not on this list. They just selected 200 people from this list. So that means the technique here would be an SRS, a simple random sample. All right, now let's go ahead and construct a relative frequency table for this data. We'll do that on the next page though. So we'll go over here. So there's our actual data. So this would be part C, so a relative frequency table. So we'll want to take their response. So very prepared, somewhat prepared, not prepared, and do not know. And we want to do the relative frequency, and normally we do relative frequency in percentage. So we're going to take each of these and divide by the sample size. So if we go back over here, remember the sample size were the 53 people that responded. So in terms of notation, this right here, this just tells us that n was equal to 53. So let's go ahead and do that. So to make this conversion, we're going to divide by 53. So we can do that on our calculator. The first one, if we did that, we'd have 12 divided by 53, and we should get about 22.6%. Then 17 divided by 53, we should get 32.1%. Then 15 divided by 53, 28.3%. And then 9 divided by 53, once we round that, we should get 17.0%. So there we go. So apparently about 22%, 22.6% of the people who responded said that they were very prepared. 32.1 said that they were somewhat prepared. 28.3 said that they were not prepared. And 17.0 said that they do not know. All right, let's go ahead and turn our attention to our newest thing, which for part D was describing the possible source of bias in the sample. So let's talk about the forms of bias. And whenever we're doing forms of bias, we always need to give a little explanation, especially since some of the types of bias can arise in several different ways. It's always important to at least give a brief explanation of why each of these forms of bias may have arisen in our sample. So let's think about what we can say here. So we always have to base this on the information that we have here. So what can we justify? Well, the first thing we can see is that we had contacted 200 students, but only 53 responded. So the very first thing that we can see here is we definitely have non-response bias. Only 53 out of 200 responded. So that's our first form of bias that we can justify here. Now notice that as soon as we mention non-response bias, meaning people were chosen and did not respond, we know that there wasn't voluntary response bias. Because remember, voluntary response bias occurs when there is no selection process. So if we know that people were selected and then chose not to respond, that means that there is non-response bias, but it also rules out voluntary response bias. Okay, what else? Well, let's go back to this information here. Notice that we haven't really talked about this too much. We use this to say that they helped select 200 students. But remember, they took these students from a list of students who signed up to receive alerts or information about emergency preparedness. So the issue with that, of course, is that by selecting from this list, right, they're not getting any students who have never signed up for any information about emergency preparedness. That means there's undercoverage in this sample. So the second form we can see here is undercoverage. Only sampled from students on this list. Now, in general, that might not be a huge problem, but of course, there is sort of an issue in this particular situation because you're asking them a question about emergency preparedness and you're choosing only people from a mailing list that's interested in emergency preparedness. So you can see sort of the issue here is that the reason that there's undercoverage is also directly related to the type of question we're asking here. So undercoverage, definitely an issue. All right, let's think about what else. Well, notice the sort of phrasing of this question, considering the suddenness and unpredictability of an emergency situation. Why is this even in the question, right? We could just ask, how well prepared for an emergency situation do you feel you are? So this part here, should probably get rid of that. That's wording bias. So wording bias, the considering how blah, 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 that really shouldn't be in there. Okay. Again, remember, for wording a statistical survey, you should always do it in a very sort of simple and direct manner. You shouldn't have any sort of that unnecessary flowery language, right? All this stuff about suddenness and unpredictability. You don't need to mention that to people because you're trying to ask them this question. You don't need to sort of sway them in any direction here. All right, now these three, I would say, are definitely the three strongest forms of bias in this. Could we justify any other ones? Well, we already said no to voluntary response bias. We could also rule out ordering bias. There's no way that there's ordering bias here because as far as we know, there was only one question. Interviewer bias would be hard to justify because El Camino College is asking this question. I don't know why people would feel an urge to say answers one way or another based on their college asking them this. So interviewer bias, probably not. Could we argue for general response bias? Perhaps. This might be a hard to answer question because how do we know how well prepared we really feel? But do keep in mind that they said that they wanted to study how well prepared students feel. So yes, you might say you might not be as prepared as you think, or maybe you're more prepared than you think. But then again, what we're asking about is how you feel you are. So perhaps it's a difficult to answer question, but I think that's harder to justify because the sample is really trying to get people's just feelings or opinion here. So I would think that the other forms of bias would be much harder to justify. These three, though, are definitely ones that there's no doubt that these occurred in our survey. All right, let's go ahead and wrap this up with one other little piece here. We wanted to say what percentage of the sample said they were very prepared or somewhat prepared. Remember, when you see the presence of that or, we know to go ahead and add the percentages. So we take the percentage from here and the percentage from here. So we take 22.6% plus 32.1%, and that looks like we get 54.7%. So we could say that 54.7% of sample said they were very prepared or somewhat prepared for emergency. Okay. Now, there was a little follow-up thing. I mean, the calculation should be very simple here. It also said, given the biases present in the data, is this percentage most likely an over or under estimate? And the one I really want to focus on here is the under coverage. We might not be exactly sure how the non-response or the wording bias has really impacted it, but the under coverage, it should be very clear how they sort of slanted this. Remember, we only sampled from students who are on a list about getting information about emergency preparedness. So that is a group that is naturally going to be more prepared than the general population, right? They have an interest and they've already taken the time to sign up for this notification list. So that means they're clearly thinking more about this. That means that this percentage is most likely an overestimate. The real percentage for the population is probably lower because it's got a lot of those people who didn't take the time to sign up for these notifications and things like that. So because of the under coverage, sampling only from students who signed up for notifications, i.e., showed interest in emergency preparedness. This percentage is most likely an overestimate. So again, our sort of logic here is that these people that we sampled from are more likely to probably be prepared for emergencies. They've taken the time to sign up for this notification list, which means they're thinking about it, which means they're probably the type of people who are more prepared. So when they answered, and we found that 54.7% of these people were saying that they were very prepared or somewhat prepared, we're not saying that the data is wrong, but what we're saying is that this is going to be an overestimate for the general student population, which is going to have a lot more people in it that didn't take the time to sign up for these notifications and probably aren't as keen on being prepared for emergencies. So this, in this case, would most likely be an overestimate. Is it guaranteed to be so? Not really. We would have to do further research to really develop that, but it's just something to consider, especially when you have something like an undercoverage where you only picked people from a certain group, and the certain group that you pick from have a different sort of response to the question that you're asking in this situation. All right, let's go ahead and take a look at a second example. We'll change gears, though, from something that's categorical in nature to something that's quantitative. All right, so for our second question, we'll stick with sort of researching university students. So we're going to suppose that a researcher wants to study how much time students at a local university spend watching streaming media per week. So to study this, the researcher sets up a table on the campus from 8 a.m. to 12 p.m. with a sign that says, "Come talk about media." Any student who walks over, the researcher asks, "How much time do you spend watching streaming media per week?" So the researcher ultimately talks to 19 students and gets the following data. So all the values here are in hours. And you can see how this is definitely quantitative information this time, not categorical. So apparently one student says that they watch 0 hours of streaming media. Somebody said 5, somebody said 9.5 hours, somebody said all the way up to 23 hours per week. So let's go ahead and identify some pieces here. So for A, we want to start with our population, sample, and individual. So again, easiest probably to identify the sample. We know that they talked to 19 students. So the sample here would be 19 students, and the individual would be 1 student. The population would be all students. And this time, all we have for information is that they're at a local university. So we'd say all students at this university. Okay. So there we go. We've got our population, sample, and individual. Let's go ahead and take a look at the sampling technique. So what did they do? They set up a table, and with this sign, any student who walks over, they ask this question. So notice that this wasn't done randomly, and there wasn't really a system. They're not choosing like every 10th person or every 20th person or something like that. So what that means is that this is a convenience sample. So it was just a convenient sample. They just asked anybody who was willing to come over and talk to them. Notice we can also probably already see sort of ahead to when we talk about the possible sources of bias. Because we just let people come over to this table and talk to us or give their value for this survey, that means there's also going to be voluntary response bias in our data. All right, let's look at part C. Let's give the 5-number summary for this data set. So we'll want to pop these data points into our list. So let's take this stuff, throw this into list 1. So if you have your calculator, stat and edit, and we get 0, 1.5, 2, 2.5, 3, 3.54, 4 again, 5, 6, 7.5, 8, 8, 9, 9.5, 10, 11.5, 12, and 23. So we should have 19 data points in there. And then stat calc 1 of our stats, we put in L1, and we'll scroll down a little bit. We want the 5-number summary. Remember, 5-number summary is the minimum, Q1, the median, Q3, and the maximum. So it looks like the minimum here was 0, Q1 was 3, the median was 6, Q3 was 9.5, and the maximum was 23. Keep in mind the units for all of these things would be in hours, since we're saying how many hours did they spend watching streaming media. Again, just to do a quick confirmation, notice that the 0 and the 23 should be obvious, min and max. In terms of the median, since we have 19 data points, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9. And notice that our median would be right there, so that we would have 1, 2, 3, 4, 5, 6, 7, 8, 9 on this side. So an equal amount of data on each side. Then for like Q1, we would split all this stuff in half. And notice that that would land right there. And we can see And we've got 1, 2, 3, 4 data points, and 1, 2, 3, 4 data points. And then finally the Q3, the 9.5, would land right there. And notice again, 1, 2, 3, 4, 1, 2, 3, 4. So we get 4 equal chunks of data, which is of course what the quartiles are supposed to do. So there's Q1, there's the median, and there's Q3. Okay. Well, we also would like to draw a box plot and describe the shape of this data set. So we can do that right over here. So remember, first step for drawing a box plot, give yourself an axis. We've got to go from 0 to 23. So I can just do like 0, 5, 10, 15, 20, and 25. So this is hours of streaming media per week. Okay. Remember, we'll go ahead and start our box at 3. So we'll put that right here. Then we'll put the median at 6 right there, and Q3 at 9.5 right about there. So there's, make those boxes. There we go. So we'll connect that. There we go. Then we'll put a tail out to there at 0, and then a tail down to 23, which is right there. So there we go. There's our box plot. Now we need to go ahead and describe the shape. Remember, when looking at shape of a box plot, you just look at the box here. So it might be hard to tell. This looks a little bit smaller than this, but they look roughly the same. So probably what we would say for the shape here is we'd say it's approximately symmetric. Now, could you maybe make an argument that it's slightly right skewed? Perhaps, especially depending on how your diagram looks. But notice if you go back over here, the distance between the Q1 and the median, 6 minus 3 is 3, whereas the distance between Q3 and the median is 3.5. So there really isn't a huge difference between these two things, meaning that really these parts of the boxes aren't that different. So symmetric is probably the best description. Remember that with a box plot, when we say symmetric, we are unable to diagnose if it is Bell normal or uniform. We just know that it's symmetric. All right, let's go ahead and determine if there are any outliers in the data set. So let's remember how to do that. First, we need to get the IQR, which we just simply subtract Q3 and Q1. So Q3 minus Q1. 9.5 minus 3 is going to be 6.5. Then for step 1, we'll go ahead and get our lower bound and our upper bound. Remember, the lower bound is Q1 minus 1.5 times the IQR. Q1 in this case is 3 minus 1.5 times 6.5. So if we do that on our calculator, 3 minus 1.5 times 6.5, we should get negative 6.75. Now, that might not make a lot of sense. I mean, how do we get a negative amount of time that we watch? Well, remember, the lower bound is just a bound. And since we can't have a negative value, that means there won't be any outliers on the low end. No value can be below negative 6.75, so we're not going to have any outliers on the low end, which should make sense, right? Because the people who said like 0 or 1.5 hours, they're pretty close to everybody else, so they're not going to be outliers. Let's look at the upper bound. That's going to be Q3 plus 1.5 times the IQR. The Q3 here was 9.5 plus 1.5 times 6.5. And if we do that on our calculator, 9.5 plus 1.5 times 6.5, we should get 19.25. All right, 19.25. Were any of our data points outside that range? Well, 12 wasn't, but 23 was. So we would have our one outlier here, the person who said 23 hours. So we would say the person who reported 23 hours was an outlier. So that person was far enough away from the rest of our data to really be considered an extreme value. Doesn't mean that their value is wrong or anything like that. It just means that it really is an extreme value, right? It's much larger, significantly sort of larger than the rest of our data there, that 23. Okay, so all this was sort of some review stuff. Let's go ahead and talk about some forms of bias that might be in this sample. So we'll go ahead and we'll do this on the next page. There's our data, which we don't really need for the biases, but that's okay. So for biases, Well, we already talked about one thing, right? Which is that since we allowed people to just walk up and put themselves into our sample, we definitely have voluntary response bias. So first one we should definitely mention is voluntary response bias. Allowed people to walk up to table. Okay. Second, what else can we justify here? Well, we might think about the question here. How much time do you spend watching streaming media per week? I mean, that's a pretty well phrased question. I mean, it specifies per week, so it has a time frame, and it asks exactly what we want, which is that we wanted to study how much time they spend watching streaming media, and we asked that. But there is probably an issue about this not necessarily being a sensitive question, but it is probably a hard question for people just to answer off the top of their head, right? I mean, we probably don't keep an accurate log of how much time we spend on streaming media per week. So these people are probably giving sort of rough estimates. So that means that there's definitely general response bias here, right? This is a hard to answer accurately question. We're not saying that it's a sensitive question. People have no probably reason to over give their answer or undershare their answer or anything like that, but it's probably hard to answer it accurately even if they try to. The third and final sort of form of bias here that we can maybe argue for is there is this information that we were only on the campus from 8 a.m. to 12 p.m. and we're trying to study everybody at this local university. That's probably going to give us a limited slice of the population. So we could also probably argue for undercoverage here, right? We were only sampled student, sort of morning students here. Now, maybe morning students have different habits about streaming media than students in the afternoon or evening. We don't really know, but we'd just be a little bit concerned because we only sampled students from the very specific sort of morning time from this university. Could we argue for other things? Well, we've talked about the two forms of sampling bias. Could there be wording bias? Probably not. Interviewer bias. It seems hard about why people would want to give a different answer just because this researcher was asking them. So probably not interviewer bias. No real ordering bias because, again, we only had information that they asked a single question. And finally, probably not any non-response bias because, remember, once you have one of the things like voluntary response bias, you can't really have the other because people weren't choosing not to respond since there was no selection process here. So these three really seem to be the only ones we could justify. All right, let's take a look at a final example, which not only will give us a chance to talk a little bit more about these biases, but also shows us a sort of final, sort of interesting descriptive statistics that we can actually go ahead and do. All right, so for this one, we're going to say, suppose that there's a large national grocery store chain that wants to study how much time its employees are idle on the job. So how much time are they basically just standing around not doing anything, right? So to study this, the researcher for the company first divides the chain into its major service areas. So they work in the West Coast, East Coast, and Midwest. Then the researcher randomly selects 150 employees from each region, so 450 employees overall. The researcher identifies themselves as working for the grocery store chain and then proceeds to ask the question, how much time per day do you waste while at work? So ultimately, the researcher talks to 78 employees and gets the following data. So notice that the data here is presented not as the raw data, because we probably wouldn't want to have to deal with 78 data points, but instead sort of in the classes and frequencies that we would have for like a histogram. So we know that there were 41 people who said that they were between 0 and 30 minutes, 25 that were between 30 and 60, 9 who were between 60 and 90, 2 who were between 90 and 120, and 1 who was said between 120 and 150 minutes. So let's start by identifying the population, sample, and individual, and identifying the sampling technique. So let's go ahead and talk about the population, sample, and individual. So for the sample, that's where we always like to sort of start. So remember that they ultimately talked to 78 employees. So our sample here would be the 78 employees. That means the individual would be 1 employee, and the population would be all employees. And what's the sort of shared thing here? Well, it would be all the employees at this large grocery chain. So all employees at this grocery chain. Okay. So we wanted to study all the employees. We ultimately talked to 78 of them, and the building block is a single employee here. All right, let's talk about the sampling technique that was used here. Well, we notice that the researcher did do this. They talks about them randomly selecting, so we know that that narrows it down to SRS, cluster, or stratified. In this case, they first did do this classification of the major service areas, West Coast, East Coast, and Midwest, and then they made sure to select some people from each region. So that does make this technique stratified here. And the strata were the regions, right? That they were making sure they got some West Coast employees, some East Coast employees, and some Midwest employees. All right, we'll go ahead and build the histogram, I think, on the next page. So we want to build a histogram for this. So usually the first step of building a histogram is to go through, get your classes, and count how many data points fall into each. But in this case, that's already been done for us with these intervals. So we just need to go ahead and construct this. So we'll draw our axes. There's our frequency. Notice that the frequencies go as high as 41. So I guess we could go by something like 5, 10, 15, 20, 25, 30, 35, 40, and 45. So we'll zoom in a little bit to get a better picture. 5, 10, 15, 20, 25, 30, 35, 40, and 45. And then for our classes, I will actually start all the way over here because the first class starts at 0. So 0, 30, 60, 90, 120, and 150. So my first bar should go all the way up to 41, which should be right about there. The second one should go to 25, which should be right about there. So we'll also go ahead and label these 41, 25. Then we had 9, which would be right there. Then 2, which I guess would be right about there. And then 1, which would be right about there. Okay, so there we go. There's the histogram based on this information. What sort of shape are we seeing here? Well, there should be no doubt. The shape is definitely roughly. Well, what do we see here? It's going this way to the right. So we have a right skewed distribution. Right skewed. Okay, perfect. So we were able to translate their information rather than having to look at the 78 individual data points and do this. They already had it in this nice sort of frequency table form, so we were able to go ahead and build this histogram. All right, we've got one other. This will be sort of the interesting part. We're going to estimate the mean and standard deviation for this data set. Now, I do want to point out that we're saying estimate here. Why are we estimating it? Because we don't actually have the exact data. And what I mean by that is if you take a look at this first class was people who said that they wasted between 0 and 30 minutes at work. And there were 41 people. Now, those people could have said 0 minutes, 5 minutes, 7 minutes, 28 minutes, 29.5 minutes, who knows? We don't actually know their data points. We just know that there were 41 people who landed in this region. So we're going to learn a technique to estimate this as best as we sort of can. So it's only going to be an estimate. So what we're going to do this, so we'll just make a little note here. This is estimating mean plus standard deviation from a histogram. The only time you would need to do this is in a situation like this where you don't have the raw data. In all our previous examples, we've always just had the raw data, so we just type in every data point. But in this case, that won't be possible. So the first thing we're going to do is we're going to make a little midpoint and frequency table. Now, what a midpoint is we're basically going to make a guess or sort of an estimate for each interval. And we're just going to do that by taking the middle. In other words, for the people who landed in that 0 to 30 range, we don't know if they said 0, 5, 7, 19, whatever. But what we can say is that a reasonable guess is the middle. Now, what's the middle between 0 and 30? Well, we can either know that that's 15 or simply take 0 plus 30 and divide by 2. So the midpoint would be 15. And of course, there were 41 people who said that. The midpoint for the next one, what's right between 30 and 60? Well, you can do 30 plus 60 and then divide by 2, or we can just common sense know that that's going to be 45, and the frequency there was 25. Then between 60 and 90, 60 plus 90 divided by 2, you're going to get 75, and the frequency was 9. Then 90 to 120, 90 plus 120 divided by 2, you're going to get 105. And the frequency there was 2. And then finally, for this single person, we have no idea what value they said between 120 and 150. We'll just take the average, 120 plus 150, divide that by 2, and you should get 135. And there was one person. So what we're basically doing is we're saying that we're going to imagine our data as 41 people who all said 15, 25 people who said 45, 9 people who said 75, 2 people who said 105, and 1 person who said 135. That's the best estimate we can do. Now, of course, we don't want to have to type into our calculator 41 15s or 25 45s, so we can do a little trick here. What we're going to do is we're going to put this data in L1 and this data in L2. So if you have your calculator, you can follow along here, and we'll clear out whatever was in L1 and L2 currently. So put those midpoints in L1, so 15, 45, 75, 105, and 135. And then in L2, put the corresponding frequencies, 41, 25, 9, 2, and 1. Then we'll do our standard thing, which is we'll go stat, calc, and we'll go to our 1var stats. But instead of just keeping the frequency list blank, a lot of you guys have a calculator that says frequency list, we're going to actually put L2 as the frequency list. So we're going to have our frequency list set to L2. Then we can go ahead and hit calculate. And if you notice, the way to check that you've done this correctly is that the n should be equal to 78 because we have 78 data points here. Now, if you have a slightly older calculator, what you will need to do is, and after doing stat calc 1var stats, you'll need to actually type in L1 comma L2 and then go ahead and hit enter. And that's the way to tell the slightly older calculators that you want to use these as your data, but these as your frequencies. One thing to keep in mind, if you have the newer calculator and you actually have this nice little thing that reminds you have a frequency list, next time you do something on your calculator, make sure to go back and clear that frequency list back out, right? When you go to the 1var stats and you hit calc, you want to make sure that it's blank for frequency lists in the future, because the only time we use this frequency list approach is for this estimating mean and standard deviation from the histogram. Either way, though, what we should get here is we want the mean, which looks to be roughly 35.4, and we can put that in minutes. And the standard deviation, of course, we want the sample standard deviation, which should be 26.3 minutes. So there we go. We got our average and our standard deviation, even though these are just the best estimates we can get from our data. So if we had the raw data points, if we actually had the 78 data points, we could have just literally gotten the mean and standard deviation. But this is our best guess based on only having this sort of this histogram information or this interval and frequency information. We're just guessing that the people who were in these categories or in these intervals were just at the exact middle of each interval. All right, well, let's go ahead and wrap this thing up by talking a little bit about some of the biases that could be in this. So, biases. All right, let's think about what was going on here. So if we go back and look at this, first, remember, we selected 150 employees from each region, so 450 overall, but we only talked to 78. So once again, without sort of a doubt here, there's going to be non-response. 78 out of 450 responded. So there's no doubt about that. What else? Well, we should be a little bit sort of suspicious about the fact that we had this researcher who identified themselves as working for the grocery store chain and then asking a question about how much time you waste while at work. So that seems like it's probably better to have used like a third party for this, because this is definitely interviewer bias, right? It's the company asking about wasted time at work. Right? We probably don't want to admit to whoever employs us about how much time we're wasting at work. Or if we do answer it, we're probably going to give a lower value than is really true. What else could we argue for? Well, I also want to just call your attention, even though this one's a little more subtle, is notice how negatively they asked this question. How much time per day do you waste while at work? That's a little bit different than what they really wanted to study. They wanted to study how much time its employees are idle. And that's probably a more neutral term, right? How much time are you idle while at work, right? We just want to know how much sort of time that you're not having to do anything. But this, we phrased it so negatively and said waste while at work. That waste probably shouldn't be in there. So we could also argue that this one has a wording bias. Waste doesn't quite equal idle. Or even if it does equal being idle, if the time from your company's perspective that you're idle is time that you're wasting, it's not a great way of phrasing it. All right, could we come up with other forms? Well, I mean, it's hard to say if there's any undercoverage here because we don't really have any information. It seems like they picked some employees from the 3 major regions that this grocery store works in, so we don't really have enough information to justify undercoverage. There cannot be voluntary response here because we had non-response. Remember, as soon as there's one, there can't be the other for that. Again, we don't have enough information to argue for ordering bias because there was only one question. We could maybe argue for general response bias, right? We could say maybe asking about the time you waste at work is a sensitive question because maybe people culturally don't feel like they should waste any time at work. Perhaps you could maybe make that argument. You could maybe also argue that the time you spend idle at work is a hard thing for you to estimate, so maybe there's a general response bias there. I think that's a little bit weaker than the ones that we discussed here, but it could certainly be justifiable. Okay, so that gives us 3 examples of not only sort of doing our basic sort of descriptive statistics, but also introducing this concept of bias. In our next video, we'll continue sort of learning a little bit more about the language of statistics by changing from talking always about statistical samples or surveys to talking about statistical studies.